This is a longer technical video about scale for my students. We've been researching historical buildings and designing them to be 3D printed. And in isolation, doing just that is fine. But it'd be nice if the whole class's projects fit together to form a little town. Scale is used to make comparisons showing how things relate to one another. It's a way to think about how big or how small something is. Time scales, magnification scales, scales to measure distance or size, ratios representing the real world. When a group of projects all use the same scale, it means they are all the same relative size. Little scale people could walk out of the little scale post office and be comfortable in the little scale general mercantile. For this 3D printing project, when we say scale the building, we mean to use a proportion, a ratio to change the size. A house that's made 1/2 the size of an actual house is a 1:2 scale. Modeling scales have a lot of naming conventions that have been used in the past. I will always display a ratio to show how these different scales relate to each other. The number on the left represents the model, and the number on the right represents the real world. Units don't matter when you scale. If the scale was 1 to 10, that means 1 foot would equal 10 feet in the real world, or 1 centimeter would equal 10 centimeters. Some different scales. If it's greater than 1 to 1, it's a larger than life model. It's something we use in science class, maybe to illustrate a flower or an insect. If it's a 1 to 1 scale, it's life size. A 1 to 6 scale is also called the 2-inch scale because 2 inches equals a foot. It's the scale used by G.I. Joe and Barbie. A 1 to 12 scale, also called a 1-inch scale, means that 1 inch equals 1 foot. It's a scale used for model cars and standard dollhouses. Older model trains used a 1 to 43.5 model scale. This was called Model O, and is based on the gauge size of the train tracks. In this scale, 7 millimeters equals a foot. 1 to 60.96, also called the 28 millimeter scale. This is a scale used in wargaming, like Warhammer 40,000. In this scale, 28 millimeters equals the height of a standard human being. 1 to 64, also called the 25 millimeter scale, where 25 millimeters equals the standard human height. This is a scale that's used in Dungeons & Dragons, Hot Wheels cars, and it's also the same size as the S-scale train. 1 to 87.1. This is the HO scale in model railways, where it is half the size of the O scale, so it's abbreviated HO. 1 to 100. This is an architectural scale. It's really easy to use, especially in the metric system. 1 centimeter equals 1 meter. 1 to 144. This is a dollhouse scale, the standard dollhouse being 1 to 12 ratio. If you were to build a little dollhouse put inside a standard dollhouse, it would have to be 1/12 of 1/12, making 1 to 144. That's kind of a gross scale, but it's used in W-scale trains, which are uncommon, miniature armor, and some Japanese giant Gundam robots. 1 to 160 is the American N-scale train. It's half the size of the HO scale. 1 to 200 is another architectural scale. It's used on very large buildings. 1 to 2500. This is used in science fiction and naval wargaming. But what scale do we use? It depends on the size of the building. I've printed one house at several different scales to see how it would look. At larger scales, more detail is captured, but longer print times, more space to display, and there are troubles with overhang. As they get really small, architectural features are lost. I think for houses, small towns, and shacks, a good scale to use is the N scale for model railways. Houses capture a good amount of detail and have limited overhang. Scene supplies are readily available. At this size, the small town I teach in would be about 15 feet long. But if you're building monuments or large buildings, a bigger scale might be needed. The Great Pyramid of Giza is 481 feet tall. At N scale, that's 3 feet, far larger than we could print. Using a scale of 1 to 1000, Giza would become about 6 inches, something we could handle printing. There are other times that it's more important to model people and the space they occupy. I think 28 millimeter scale, 1 to 60, would be good for this. There are lots of supplies, tutorials, and capture sufficient amount of detail. But how do we do this? It's best to work from actual measurements and do the math. You need to stay consistent in the units, converting from one to another, and then scaling them into something that we can use in Tinkercad. An easier method relies on art skills. Measure the building indoors. Doors are a pretty standard height. If I'm looking at a photo, I can make a piece the size of the door in that photo and use it to measure the height and width of the building. In N scale, the doors would be about a half an inch or 12 millimeters. I can multiply my door sizes by 12 millimeters to figure out how big to make the object in Tinkercad. Or I can just make it look right. I draw the structure based on proportions, and then I hold Control on the keyboard and stretch the whole structure. This adjusts the whole building proportionally in all dimensions. I adjust it so that a 12 millimeter block can fit through the doorway. There are times that a smaller door, like small mining shacks, or larger doors, state buildings, are used. Use the same strategy, but nudge the size. Make the door 10 millimeters or 14 millimeters. When in doubt, I load a building in the same file as one I know that is right. This could be Tinkercad or the slicing software, and I adjust the one I'm unsure about to make it look right. That's it. Scale is a ratio we use to change the size of a model to get a different view of it. It takes a bit of math, but we can use it to produce a variety of structures that will all fit together. And for little model towns, 1 to 160 ratio, the same size as N-scale trains, is a good starting point. Thanks for watching.